With simulation nodes, we can simulate mud, snow, paint, ripples, and more. And it is all based on simple logic. It's a perfect introduction to simulation nodes, and this tutorial also has a ton of bonus content that you can get for free. So how do we make a track like that? Well, we need 4 things. We need a ground, we need a boot, and we need to move the ground down when this element hits the ground. And then we need to displace some mud where the object is so that it kind of looks like mud. And we need to do this for every frame of our simulation, and in the end we have a really nice animation of tracks or footsteps depending on the animated object. So let's start with our list. So the first thing that we actually need is Blender 3.6, and we need the ground. So to add the ground, let's just add a plane, and here it is. And the next thing is a boot or something to animate on a character. And you have 3 options. You can either animate yourself, or you can get a character from Mixamo, or you can, for example, use your Coco video to kind of like a motion capture yourself from a video and get a character with your proper animation. You know, I'm just going to use the Mixamo character. I'm also going to link this thing down in the description in case you need the same character. And now we have the character as well. And the next thing that we need is to move the ground down where the feet of the character hits the ground. The foot of the character hits the ground, something like that. And well, currently we cannot do this because this plane doesn't have any resolution. So let's subdivide this to something like that. And let's see. Okay, currently only like a little bit has to go down. So I'm gonna move this thing into the mud, this character. So I'm gonna move the armature down on the z-axis like maybe that. And now let's see what should happen. So when the feet of the character is inside this ground, the ground should move down. So in our case, it's like those points here, they should move down. And not just by any amount, but the amount that is the distance between them and the point of the boot below them. So how should we do this? Drag a new workspace here, geometry nodes, and let's add them on this ground because that's what we want to modify. So I'm going to add new nodes and we'll call this ground. And since we want to move the position of our points here, there is a very good node for that, which is set position. So let's put this here. The solution is the following. We're going to hit, or we're going to shoot the ray from each point down like that. And then we're going to see, all right, did we hit something? Did we hit the boot? And if we did that, then let's move this point down to the distance where this hitting happened, you know. So to cast some rays, we can use a ray cast node. And this node is, you know, it's one of the most complicated nodes in my opinion. It took me like ages to understand what it actually does. And it actually is very simple, but maybe I was stupid, I don't know. Anyways, what it does is it has target geometry input. And it is very important to understand that the target geometry is the geometry that we want to hit with the rays. So we want to shoot some rays out of somewhere and we want to hit the target, which is our boot. So let's open our armature up and let's drag in the character 15, which is our mesh. Now you don't drag in the armature there directly because the armature is just, you know, the purple or the orange part inside. It's not the mesh, the actual mesh. So this is our character. It's currently the wrong location, as you see, like something massive here. And that's because the position is set to original, but it has to be relative to be in the exact same location where it actually is. And now we want to hit our character and we want to shoot the rays down. We want to shoot them downwards to see if something is below the ground. So this is already the default thing here, vector -1, so the ray direction is pointing downwards. Very nice. And well, to get something out of here, let's see, is hit. We don't see anything. The reason is that if you want to visualize an attribute, it has to be visualized in the context of something. Because, you know, otherwise, how does Blender know if it has to show this attribute on which object and where or what? So let's just visualize this. And we see we have, I'm going to just delete those. We have like 1, 2, 3, 4 points that are hitting and that are inside the boot here, which is very true, as I verify. So now we need to move them down. And what we can do is we can drag the is hit to the selection here. And now we can move them down and up like that. Only those points that are hit. So for example, if I now move the character around, you see they move down, but they don't move down by the correct amount. And I'm also going to pin those nodes so that when I select the character, it doesn't disappear here. So we have this hit position thing here, and it outputs for each point where the hit occurred. So we can just move the point there and make sure the offset is 0. And now it, moved them into the correct location. And if you subdivide the mesh, subdivide mesh node, then you see the more we add the details, the more, it looks like it takes the shape. So if you, for example, add some offset here, like maybe just add this upwards, you can see this is like the shape of the shoe actually. But obviously we have like a lot of detail. Currently the mesh is really dense, so we don't need that. Let's maybe put like 2 here. This is enough. We have moved the ground down, but we have a problem. So if you play this animation, you see we don't have any tracks, and that's because we don't save the progress. So what should actually happen is that on each frame, we should do the same thing, move down those points that are hit and keep the old ones where they were. So for that, we can use simulations, because the simulation zone in geometry nodes gives us information about the last frame and execute this on every frame. So the first thing that you notice is everything disappeared depending on which frame you were. So the simulation nodes work on every frame and they need the context of the last frames. So you cannot just, select random frames and expect this to work. Press Shift, left click, and go to the first frame. On the first frame, you can always see the real-time modifications. So if you work with simulation nodes, work on the first frame. Why is it so? I'm just going to turn off those nodes right here, and I'm going to add transform nodes. For example, I'm going to add a scaling node that makes the ground a little bit smaller, as you see. Now I'm going to add a rotation node that rotates this by 2 degrees. And in the end, I'm going to add another node that's going to lift this thing up by 0.1 meters. Like that, maybe 1 meter, like that. So what happens now is that the areas before the simulation nodes are going to be executed once, and the areas after the simulation nodes are also going to be executed once. But the things happening inside simulation nodes, this transform here, is going to be executed basically infinitely, as much as you have frames, currently 250 times. So now when I press this, thing is going to start to rotate. Why is it happening? That's happening because inside of this simulation, we are on each frame rotating by 2 degrees. What is happening before that, it doesn't matter. It only happens once. But for example, if I would take the delete this one, and when I put this one here, it's going to shrink like that, because it's going to do the same thing on absolutely every frame like that. So this is an important thing to understand about simulation nodes. You have to think about them like doing things like that, basically. So using this knowledge, we can get going with this stepping. So let's just take this set position, and I'm going to move this here, and I'm going to connect the is hit and hit position here. And I'm going to enable the nodes, go to the first frame to see what is happening, and press play. And look at that. The steps are here. The steps are in the correct place. It saves the progress, because on each frame, it's only going to move points that are hit. It's going to ignore all the other points, including those that already were hit like 20 seconds ago. So this is why it works. Okay, and now a very important thing with simulation nodes, just add a frame here, and you can type like move ground down, so that you actually understand what happened here, so that, when you have like a large node tree, you actually get what you did there. So this is good and all, but the resolution is extremely bad, so I'm going to enable the subdivision. And now it looks much better, but we are missing something crucial here. Number one, the ground is too small. So let's make a larger ground. Let's go to edit mode. Let's delete this thing. Let's add a plane. And I'm going to grab and move this by -4 meters. And I'm gonna add 2 loop cuts so that when I now subdivide everything, it's gonna be kept nice and squarey. Quad faces, that's important. So something like that. And now when we replay the simulation, you see we have our nice tracks. Looking nice. But the problem is those tracks are missing our 4th step, which is adding the muddy border. How do we add this? And let's go to the first frame. And how can we add something as a muddy border? First, we need to know where our step is, and we can get this from the isHit attribute if we preview this. Now you see some mess here, and that's because we have already moved the ground down by a little bit. So we can just turn this off for a moment. And now the muddy border should be, how do we get like around this attribute? How can we propagate? For that, we have a nice node called blur the attribute, which is, so what is blurring? Blurring is basically using neighboring values. You know, I'm going to show you what it does. It's going to increase in size. And currently, it's the float attribute is being displayed as a Boolean attribute, which is why it is so white and large. But if we re-add this, add this node back, you can see it's nice and blurry, you know. So this is how blurring works. It's going to take the values and like mix them around with the neighboring values. So let's add like, I don't know, 6 iterations here. This looks nice. And now let's move the ground up by this thing here. So I'm gonna copy and add a new set position node. I can enable this safely because it doesn't have any content. And well, let's connect this like that. We have a mess here. Why is this so? One of the reasons, or the only reason, is that we have actually 3 inputs here. So if we just plug a float value into vector input like that, it is just gonna move them on all the axes at the same time. We don't want this. So a solution for that is a vector math node, and we can take a multiply, and what it does is it's gonna first create a vector with 3 components, just as it did here, you know, vector with those same values, but we can only keep, for example, the z component here, and now it's only gonna move up. If you add a little bit of, you know, x and y, it moves around, but we only want the z component. And we can also use this to scale this thing down, so like 0.1, for example. And you see a massive problem. Like you usually see with geometry nodes, massive problems. Anyways, you see we have this thing here and nothing changed. When I change this value, that's because I'm on the 2nd frame. I have to be in the 1st frame for it to work. Now this works in real time. And the problem is that it's going through the shoe. It is also displacing inside, but we shouldn't be displacing the inside, only the border of this thing. So let's multiply the inside with 0 in order for this to be nothing. And okay, let's take a mix node, for example. And with that, we can mix between the original value and 0. Or I don't know, any other value. We can mix between 11 as well if you want to. But we're going to mix between this one and 0. So when the factor is 0, it's going to use the first value. When the factor is 1, it's going to use the second value. So we actually already very conveniently have a mask like that. We have the inside being white. So if you put this here, it's going to look like that. It's going to multiply the inside with the value that we chose. So let's keep it like that, but it's very sharp, you know, very sharp and jagged. So let's blur the factor a little bit. Not by that much. I think maybe like 2 iterations is fine. It's looking pretty okay in my opinion. And if you want to, you can use a color ramp, add some more contrast to tune this thing. But I feel this one is pretty okay right now, so I'm going to keep this like that. So this is how the nodes are looking currently. As you can see, nothing complicated. Let's move forward and let's see why it doesn't work. So if we play this right now, we see something not very realistic. You know, it's actually very bad. So in the end, we have a very massive problem, which is that the mud is kind of just like blowing up like a fountain. That's the word I was looking for. So we kind of need to tell the mods, all right, I've been stepping here for like 5 frames. That's enough. I'm not going to affect you anymore. So when the character has been standing in one place for more than, let's say, 5 frames, we shouldn't displace anymore. Or told the other way around, let's displace the mod for only the first 5 frames when the character is standing in one place. So how do we do this? Sounds pretty complicated, right? But let's start, de-packing this thing. Let's start to understand step by step why this is happening and how we can solve this. First, let's go to the last frame where this is happening actually. I'm gonna go to like 160, set the simulation node start to here, because here my character is standing and I can like conveniently have the problem coming up over and over again. This is happening because the mighty border is being created on every frame. As you know, simulation nodes, they work in cycles. It goes like that, then it restarts. And unless there is something blocking the way, something telling it to stop, it's going to happen every frame. So we need to find a way to, as I told you, to tell the simulation nodes that, 5 frames, that's enough, don't work anymore. All right, so what we can use is that we can add a scale node here. So when this is at 1, it's going to happen. When this is at 0, it's not going to happen because it's multiplied with 0. So this means the offset is 0, nothing happens. And we need to input here the information about the frames the character has been standing in one place. First, let's get information about where the character is standing. And we can get this from the isHit attribute. This isHit output here. I'm going to visualize this. I'm going to turn off all the nodes that we have here so we can focus on this one. And we see the character is standing here. So my idea here is that each frame we're going to add the standing thing basically on top of each other. So if on the first frame we are standing here, then on the second frame we are standing here, then we're going to add them on top of each other and we can see, all right, we were standing in the same place for 2 consecutive frames. And if you, for example, move around, then it is very easy as well. It just lives as kind of like a map or like a heat map or where we were. So let's do this. First, let's store an attribute. So I don't know how much you'll be doing with attributes, but an attribute is basically like in programming, it's a variable. In Blender, it's called an attribute. The attribute can contain different things. For example, it can contain different types of data. It can contain a float, integer, a vector, a color, a byte color, a boolean, and a 2D vector, which are all very useful for different purposes. But currently, what we want to have is arbitrary random values. We don't know even what yet, so a float is doing very well. And we can, for example, call this one history, where the character was standing, and currently the value is 0. Not very useful. So where can we see this useful 0? If we add a named attribute node and we select the history attribute, we can see blackness. But if we increase this value, you can see it is changing. And it clips out at 1 because that's how Blender's viewport works. But actually the value is larger. So let's do so that we, for example, put the isHit attribute into the history. And we play this. Well, exactly what is expected is happening. So on each frame, we just come in again and rewrite the isHit into this attribute. So really nothing accumulates over time. So what we should be making sure is that we actually get the information from the last state of this attribute as well. So I'm going to show you how this works. I'm going to move this one down and move this one here. And now I'm going to take a named attribute. I'm going to take the history attribute, go to the first frame, and I want to make sure that on each frame, we are going to add the current hit and also the last state of this attribute, like that. So now if you play this, you see it's getting brighter. Like on each frame, it's getting brighter and brighter and brighter, which is exactly what we want. So I'm going to add a little frame here to understand what I'm doing. Add previous hit to current and store step history. That's the thing. So let's see how this works. Let's just set our frame back to 1. Go to the first frame. And, sometimes it glitches out. You don't see the ground. Let's just, switch around and let's play this. I'm currently previewing the history attribute. And if you play this, you're like, well, does look pretty nice, like tracks. But how the hell is this a history attribute? You don't see anything like a history here. Well, you don't, because it's hidden. It's a secret. So if you add a division node, because the problem is the values are, so large. If it stands for like 7,000 years in one place, the viewport is still going to clip out at 1, so you don't see anything different there. But if you divide this thing with, for example, like a value, you can see it turns into a heat map. And you can see where the character was for the longest time. Actually, the longest time, you see, one footstep, seems to be the toe part, since this is like the brightest area. Pretty cool of a heat map, I would say. You can use this for colors and all the stuff I'm going to show you in the end of this tutorial. And what we can do with this attribute now is to compare this. So let's add a compare node. And so as you remember, our rule was only displays for the first 5 frames of being in one place. So let's add a comparison here, and let's output all the areas where the values are smaller than 5, like that. So in those areas, the character has been standing for less than 5 frames, and in those areas, the character has been standing for more than 5 frames. We can, change the stuff as well. More than 18 frames, the character has been standing in those places. But let's do less than 5, like that. And now we should use this somehow to, multiply our displacement with this value, so that I'm going to go to the frame 160 to show you, so that when the character, for example, is standing here like that, then the black value just kind of like cancels out the displacement. So let's do this. I'm going to delete this node here, and I'm going to move them here where we create the muddy border, and we have our displacement here. I'm going to enable the muddy border, so now it starts to grow if we turn this on like that. If we plug this in here, let's see what it does. It does the same thing. Well, this is actually pretty logical, because when you look at this thing, I'm going to go to the first frame. I'm going to turn this one off. The black area is inside here, the area where we don't have displacement. But the displacement factor itself is pretty large. So the black area should be actually larger to cover this, to make sure that we actually, cancel it out. So how do we make things larger? With a blur attribute, of course, which is a godsend node. So we blur this and doesn't do what we want to do. That's a shame. So the problem actually here is that, when you think how the blur attribute works, it's going to take brighter values and it's going to, blend them, it's going to grow them out. So, well, we just have to make an inverse of this. So let's add a greater than actually. Let's add this blur attribute. Let's blur this for 20 times like that. And now let's add another greater than. And let's say if the values are greater than 0, it should be our selection. Oh, this is very large. So we actually should be, I want to put this like 0.01 actually. It's like more of a circle. And like 30 iterations. I think it works very nicely around this. It is definitely larger than this muddy border here that we have. So let's try plugging this here. Well, actually, this is the inverse, because let's see, 1, 2, 3, 4, 5. All right, it starts displacing after 5 frames. Not what we want. We have to set this to less than. So this is now the inverse. Let's plug this into our scale. And let's see if this starts to work. So showtime. Let's press first frame, second, third, fourth, fifth, and it should stop now. And it's just stopped. It works. It's perfect. It works. If this happens to be too small, for example, only 10 iterations, you might, you see, you have like those little things growing from the edges because the area is too small. So I recommend you add like 30 frames to be just, sure. And now this it just works very well. Where can you change the speed of this thing? You can change the speed from here. You set this to 0.01, then it's gonna, on the 5 frames, it's gonna displace 0.01 on each frame, which is gonna result in the end length being like 0.05, right? If you set this to 10 frames, it's gonna get higher and also, you know, be a little bit slower. 20 frames like that. So you can like give different imitations of ground with this technique. But I think 5 frames is okay, and you know, height like that seems to be working pretty nicely. I think I'm maybe gonna like make this a little bit larger like that. And now let's go to the first frame and let's see how our animation looks. Are the steps nice and bordery? Oh, they are. So we have finished with our list. And how do we make snow and mud? And what is the difference between them? Difference is very simple. So if you want to make snow, watch closely. Move the character down and play. And well, we have forgotten actually to move the ground down, which is a shame. So if you move the ground down, you see you have snow. You have snow tracks, but they look extremely jagged. This is bad. So to make things a bit smoother, what you can do is add a set position in the end, and believe it or not, but for the 100th of time today, we are going to use the blur attribute node because it's kind of a solution to everything, you know. So set this to vector mode and you blur the position. So if you set the position to just position itself, this is one of the most meaningless setups in the whole history of Blender, but if you blur this, it makes sense. Then it's reasonable, you know. You can put 0.5 here and it's not so digital and sharp anymore. It actually looks much better. And this is executed after the simulation. So it's not like doing this to the infinity. If you were to do this inside of the simulation, then this would happen on every frame. And this is definitely not what you want because look at that. You know, it just blurs everything out like that infinitely. We don't want that. So you need to execute this only once after the simulation. And these are the mud tracks, snow tracks, sorry. And if you want to get mud tracks, you just move this a little bit more up and you get single footsteps. Of course, if your character, you know, if you animate your character, you know, manually, you know, your scene, your story, your animation, you can do so that, you know, you can slow down the feet when the animation happens and so on. So you have more control, but I'm using like a pre-made animation. And this is why I like cannot mitigate the issue of those trails fully. However, you notice one more thing here, and this is the time step issue. So if I add more detail here and I'm going to play this, you notice like this is weird, you know, this is like in Photoshop where a brush is like has such a large step. And that's because, you know, when you look at the animation happening here, you see it actually happens in discrete time steps, which is like, you know, everything on computers happens with discrete time steps. And this is something we cannot avoid, but what we can do is we can decrease those time steps to make this happen more often. So what you can do is that you can go into your project settings and keep everything like it is actually for now, and take the animation of your character and press SX2, and this makes the animation twice as slow. So now the character is twice as slow and the animation is twice as long, but you see the steps here are much less noticeable because they're much denser together. And you're telling like, okay, well, the animation is going to be in slow motion. I have to render all of those frames. You don't have to. You can go to step and make sure the step is set to 2. So it renders every second frame, which is, you know, great because you get the same speed, but you get the additional time steps in between. And the animation looks just as it was before. If you're using motion blur, you know, if it was previously 0.5, now it has to be 1. It was previously 1, now it has to be 2, and so on. Now, you notice the performance of this thing, 30 FPS, what is that? Well, actually it's great, but let's say, you know, you want more FPS, then pay close attention. You're gonna see where your character walks, and it's gonna stop right here. You know, your scene is ready, you know your character is gonna do this animation. So then what you can do is that you can selectively subdivide the areas where the character is walking. So press C, take the tool, which I don't know the name of, and select those areas here. Select them like that. And do like fit, and when you have selected all those steps, you know, you can just press subdivide and you can selectively subdivide them, which is something that is very nasty to do in geometry nodes. I couldn't do this. That's why it's nasty. And if you go into start, you have those subdivided areas for you. And in geometry nodes, you can now decrease the subdivision by, for example, to the same level. And now by 2 levels because you subdivided by 2. And now the FPS is much higher because only the areas that actually matter are subdivided. Also, another thing you can use is that you can delete the part of the character you're actually not using. So currently our character, I'm going to hide the mesh. Currently our character is looking like that, but I'm telling you that most of this character is useless for raycasting. So what you can do is you can take the position and you can delete the upper part of this character. You can get the Z position of all of the points of this character, and you can use comparison, and you can everything that is greater than, let's say, 0.1, really close to the ground, is getting deleted like that. And you can put this here. Now the character looks like that. That's not anything amazing, but it works for us. And before the FPS was 52, and now the FPS is 60. Very nice. So it works super well. But now you want to render this for sure, because why are you doing things if you cannot render them? This is true. So if you go to shaders, you need to select the material you're going to use on the ground. I use this desert and kind of snow things, but you're going to, of course, build your materials yourself, or you're going to use those files, which I'm going to get to in a minute. And you have to enable this material, or to set this material in the end of your geometry nodes node tree as well, this material. I'm going to call this actually ground so that it's very clear. And all the attributes you have ever used in your node tree are going to be available in shaders as well, which is great. So you're going to add an attribute node, not color attribute, just attribute. And this one is a scary node, because it doesn't have a drop-down menu. It's kind of, you have to know what you're going to input here. So let's put here history. Press enter, Ctrl-Shift-Click, go to rendered mouse, and you can see the history of your steps in shaders. But they do have some nasty issues here, and that's because of the order that we are doing things. So we are moving things down, and after that we're gonna do the muddy border and step history, and this is not a very good thing to do. So what I recommend is that you move this thing here and you reconnect the hit position and position. Now let's see if this works better. It works better now because we move the ground down after, so we get the accurate position of where the ground was hit, where the boot was hit. So you get the track history, but it's still, it doesn't have a nice resolution. You might be tempted to add 7,000 levels of subdivision to your plane, but this is not a good idea because nobody has a computer that powerful. So our helper in this case is, believe it or not, the blur attribute node. So take the blur attribute node, take a named attribute node, and take the history attribute. And in the end of the node tree, after the simulation, execute it only once. We take the history attribute, we write it to a history attribute. Currently the history attribute is just, we rewrote this, overwritten, whatever. You can tell me in the comments how this word is used. Overwrote this attribute with same attribute, but the blurred version. So, you can blur this, for example, 3 iterations. And now if you go to shaders, you can add a color ramp, and you can, get a pretty nice and sharp outline here, which, before would have been horrible. Now it looks very good. And now you can use this, for example, as the base color or as the metallic factor. So if you, preview your things here, you can also, you can do like that. Not a very correct setup, but you can understand you can use those attributes, right? And if you want to render your animation, make sure you bake beforehand, so it is in memory. So now I want to know how to make this mud plus water interaction, those paint trails and smoother tracks. I have good news for you. You can get all of this for free. So you want to learn GeoNodes, and I want to make the best GeoNodes course in the world for you. I've already involved quite a lot of 3D artists in that, and the course is going well. But now there is an official launch page where you can go, you can sign up in the waitlist, so you can help guide the course development. So I will ask you things from time to time, like which topics you'd like to be included more, what do you think of this curriculum, and so on, to make sure it actually fits your needs once it's launched. So if you sign up for the waitlist, you can get all this track simulation bonus content for free, and that's it. So sign up and let's build the best GeoNodes course together.